Welcome to Rges Algebra 2. This is lesson 22A, and we'll be dealing with section 6.6, which is the last section of the chapter, and then we'll do our check for progress, which probably will require very little instruction from me. Okay, so now we are going to talk about solving simultaneous equations or a system of equations with three unknown numbers. So if we have three unknowns, we will need three equations. This is the general idea, with three variables each. And that's what they give us here in our example. They're going to give us, I'll put it on pause while I write it out. So your basic idea is you're going to use any two of these equations to eliminate one variable, and any other combination of two of the equations to eliminate the same variable. So you want to take a look and see what you think would be useful. I think it would be very useful to eliminate z here by using those two. And so then I can either choose to eliminate z with these two or for the first and the second. I'm going to use these patterns. So I'm going to first use this and this to eliminate z, and then this and this to eliminate z. Well, when I'm looking at the first and the third, you know what, I'll just go ahead and write it out so it's very easy for you to see. Now I did that because it makes it easy with my z's right there, and so I'm going to get 4x plus 6y equals 16. So that's the first step. Now in the second step, I'm going to write out equations 2 and 3, and then I'll have to do some multiplication. Actually, let me go ahead and do that in one step if you don't mind. I'm going to, still eliminating my z's, I'm going to multiply the second equation by 3, and I'm going to multiply the third equation by 2. And because they're opposite signs, I don't need to do anything else. So let's do that on the next line. So now I'm going to add these two together. Notice my z's will also drop out. I must drop out the same variable. And I will get 12x plus 11y equals 34. Now what I have is I have two equations in two variables. So this brings it back to what you've been used to doing. But I'm going to go ahead and I'm going to add those together, and I will multiply this one by a -3, so my x's will drop out. So let's carry that to the next line. And now my x's will drop out. I will get -7y equals -14, and y equals 2. And now I have solved for my very first variable. Now I'm going to plug that back in, something that has both the x and the y's. How about this one? And I will get 4x plus 6 times 2, or 12, equals 16. Take the 12 to the other side by subtraction. You get 4x equals 16 minus 12, or 4, and x equals 1. And that's my next variable. And now I just need to do take both of those. I should have come down or gone up a little higher, but I'll take my very top equation, and I will plug in both an x equals 1 and a y equals 2 and solve for z. X is 1 plus y is 2 plus 3z equals 14. Whoops, I forgot to record that. So actually what I did then was, after I solved for x, then I took the first equation right up here at the top, and I plugged in values for both x and y to solve for z. And now I've got values for all three variables. So fundamentally, to review, this is not much different than what we've already done with two variables. The thing is, you will have three equations, and you need to use two combinations of two equations to eliminate the same variable both times. Then you're back to solving for two equations with two variables with two equations. Once you've done that, you plug them all back in to get values. Now I'm going to show it to you one more time. So here's your first problem, and I'm going to go work it out with you, and then when you go to do your problem set, try to do it by yourself. You might even choose another method, because you can see I have lots of choices on what I'm going to do. I could eliminate z's, I could eliminate x's, I could eliminate y's, just in lots of different combinations, okay? So I think because I have a negative z here, I think I'm first going to eliminate z's by using equations 1 and 2, and then by using equation 1 and 3. It will require one multiplication each time round. So the first thing I'm going to do is use 1 and 2, and I will multiply the first one, the first equation, by a 4. So I'll get negative 4z plus 4z. So that'll be my multiplier. So let me copy those two down. On the next page, or next lines, I'll get 4x plus 12y minus 4z equals 40. And the next line does not need any multiplication. 2x plus 5y plus 4z equals, that's an equal sign, 57. We're adding straight down, recall? And this will be 6x plus 17y. These will cancel out, which is what I wanted, was to eliminate z's, and that's going to equal 97. So that's one of my two variable equations. Now for the next two variable equation, I'm going to use 1 and 3 of the first three original equations, and I'm going to multiply the first. Oh boy, I keep forgetting to hit the record as I'm explaining, but what I did in that next step then is I've boxed both equations that are in two variables. I'm multiplying the top one by 5 and the bottom one by negative 6, so that my x's will drop out, and now I'm almost finished solving there for y. So I'm going to put it on pause again. I apologize that I forgot to put it on record last time. Okay, so we get y equals 5. Then we'll plug it into one of these two to get my x value. 5x plus 25 equals 35. And so x equals 2. We'd subtract 25 from 35. We get 10 on the right side. 5 and then divide by 5. We get x equals 2. And then go back to one of my original equations. I'll just take the very top one and plug in both of those values. X is 2. Y is 5. So 3 times 5 is 15. Minus z equals 10. And so we get 17 minus z equals 10. Subtract 17, and you get negative z. 10 minus 17 is negative 7, and then z equals 7. And to check that, you would plug in, for all three of the original equations, you'd plug in 2, 5, 7. So what I've done is I've solved for my y down here. Y equals 5. Then I'd plug back into one of the two variable equations. I plugged it in here to get x equals 10, and plug both the y and the x values into one of the three variable equations. I chose the first one, and plugging that in, I get z equals 7. writing it out as an ordered pair, which is no longer an ordered pair. It's actually a 3, right? It's an ordered, I don't know, triad, something. Okay, we get 2, 5, and 7. So that shows you how to do that twice. And your check for progress, I had you skip number 6 because it's a little more complicated. It's the same idea as our UV, but we'd plug in B plus 1 and A plus 1, and I skipped those for you. Don't forget in number 5, you also have, you're also going to be using the U and V. U equals 1 over X and V equals 1 over Y. Go back and review that if you need to. I'm only asking you to do 1 through 5 and number 9, which is a word problem based on this 3 variable technique. And that's all you have for this class.